So, good morning, Dominic, and welcome to today's podcast. My name is Shivani, and I'm a master's student in wind power project management at Uppsala University Campus Gotland. And I'm really excited to be hosting today's session, where we'll be exploring an incredibly important topic in the energy transition, trends in energy storage. So today I'm joined by our guest lecturer, Dominic Grondin. He's currently an associate professor at the University of Reunion Island, where his work focuses on energy systems, renewable integration, and sustainable technologies. He has an extensive experience across academia and industry, particularly in smart electrical microgrids, energy storage, and climate energy strategies. Over the years, he has led several research and development projects in intelligent energy systems and has contributed to advancements in clean transport and energy storage solutions. He also completed his doctoral research in Grenoble INP, focusing on high temperature steam electrolysis using solid oxide electrolyzer cells. We're very happy to have you here today. Welcome, Dominic.
Thank you for this warm welcome, and it's a pleasure for me to be present here and to exchange with very interesting students in this master degree.
To start us off, I'd like to dive into the technical side of energy storage. So what are the current biggest technical limitations of existing energy storage systems, particularly lithium-ion batteries, and how close are we to overcoming them?
Yes. Today, the dominant technology is lithium-ion technology, and it's dominant for good reasons because it's high energy density, low self-discharge, and it's commercially mature. But this technology facing physical and chemical limitation. First of this limitation is energy density gap. So there's still a gap between the theoretical and practical energy density. So to avoid degradation, the operator cannot use the full theoretical capacity to use the battery safely. So we are not close to overcome this limitation today. So we really need new architecture for the electrodes, for instance. We have some chemical problems like dendrite formations in the electrodes. So when you use the lithium-ion batteries, you have an uneven deposit of lithium ion on the electrode, and it can form needle-like crystalline structure. And this structure can perforate the electrolytes and can lead to some major degradation. One of them is a thermal runaway. We can have a risk of fire that can be a big issue. And today it's a major risk for the lithium-ion technology as the energy density rises with the project, and this thermal runaway become a very big risk today. So, and another one, the last one, is a capacity fade over time. So the aging is non-linear. So we can observe in some projects some sudden decline of the capacity of the batteries, and especially in demanding applications. So progress are made to overcome these limitations, but as it needs not incremental solution, but new architecture, new manufacturing process, and new technology. So it's not, we are not too close to overcome them today.
Okay, that's really interesting. Building on that, beyond lithium-ion, which emerging technologies do you believe have a greatest potential for large-scale renewable integration?
So in energy storage, you have different family, you have different application for your energy storage, and it depends on the services you need to give to the grid. So in the same family and category of the lithium-ion battery now, the dominant technology, the most credible in near term is the sodium-ion batteries that will replace lithium by sodium, and especially for stationary storage. As you can improve the supply chain's resilience using a sodium. It's very well distributed over the world and will resolve some geopolitical issues regarding to lithium. You can have some good efficiency for the systems. You can reach 20,000 cycles without major degradation, so it's good. But today it's facing the challenge of scaling the manufacturing of this technology. Another one could be the redox flow batteries, especially the vanadium redox flow that is the most commercially mature today, that can decouple power and energy and can have a longer energy duration than lithium-ion, so it can provide long-term energy, let's say. Yeah, and moreover, in these redox flow batteries, organic or iron-based redox flow batteries are gaining more attention because they can also increase the resilience of the battery.
It's exciting to see the many alternatives that are being explored. For project management perspective, what are the biggest challenges in implementing large-scale energy storage systems?
So I would say it's not technical properly. It's not about the batteries, the chemistry. It's more about permitting and grid integration. So to have the authorization to inject the energy. Another point is very crucial is financing and revenue, and because we can have some revenue uncertainty. So it's another major point to major challenge. Yes, we are facing this in Reunion Island, for instance. Site selection is also a very difficult problem to solve in the project management. And yeah, of course, you need, regarding this site selection, you have the fire hazard that you need to manage, and you have the community engagement and acceptance that is really important too.
Oh, that's a valuable insight. Moving on to a broader perspective, I'd like to talk about the industry, where the industry is heading. What major trends do you see as shaping the energy storage sector over the next 5 to 10 years, and which technologies or markets are likely to lead?
I think that's the major question today for the sector is, are storage become integrated to grids, planning, markets, and operations. So one of the major trends for the coming years is to have some grid forming storage. So grid forming is the capacity of the storage to ensure some frequency regulation also, and to add this security block to the storage inside the storage. We need also to restructure and to diversify the supply chain to avoid some big concentration over one technology, and so in order to enhance the resilience of the market, you need to diversify all the technologies and the supply chains. We need also long-term storage. So we need to provide some energy for days or sometimes for months. And this storage now is more at the pilot scales, and we try to tend to commercial scales. And we have more and more hybrid projects. Hybrid means the renewable production plus storage on one same site collocate. And this trend is actually here, and I think it will be go higher and higher. And finally, the electric grid is more and more digitalized, and so we have more and more digital platforms to optimize the dispatch decisions in real time, because you need to balance the grid, the market price, the grid signals, the weather forecast, the battery states of health. So everything need to be taken into account to make the better decision for the life cycles and for the to higher the revenue of your energy storage system.
It really shows how dynamic and fast evolving the field is.
Yeah.
Do you believe energy storage will become a key factor that determines how quickly renewable energy can replace traditional fossil fuel systems?
Yes. Energy storage is necessary because it solves the temporal mismatch between renewable energy production and energy use, but it will not be sufficient to ensure that we will replace fossil fuel, because we need other aspects to be dealt with. So we have transmission infrastructure. So we need the capacity to integrate this renewable energy. We need to deal with grids, permitting, policy for the renewable production itself. But yes, energy storage will help and is necessary, especially for seasonal storage, because today the seasonal storage is mainly ensured by the fossil fuels. And yeah.
Another important aspect of this topic is sustainability. And as demand for batteries grows and concerns around raw materials, mining, and waste are increasing, how can the energy storage industry balance rapid growth with sustainability and environmental responsibility?
Yeah, the main sustainability tensions today regarding the energy storage as critical materials needed for these technologies. The supply chains involve ethical and geopolitical risks, and some solutions that can be imagined or could be used as to develop a circular economy. So we have more and more projects regarding using second life batteries from the mobile sector, so from the EV. We can design the battery pack can be repaired without destroying all the pack, and just change some cells that can be in default mode. So yes, it's about designing better and to reuse when it's possible, and at the end can be able to recycle as much as possible all the materials at the end. We can also have some material desertification, to not put too much pressure on just one resource. Regarding this resource, we can search for responsible sourcing, so to certify the location of the source. We can also think about using safer chemistry. We have some problems with fluorine component, so to switch to other components that is safer for the environment, it's also one solution that should be investigate. And at the end, regarding the land use, it could be good to co-locate as much as possible the energy storage to existing industrial or grid infrastructure. Yeah.
To wrap up, I'd like to ask something from a student perspective. For students in wind power project management who want to work in the energy storage sector, what technical skills, industry knowledge, or career strategies would you most recommend focusing on today?
Regarding the technical skills, I think a fundamental one, what could be needed for comparison of the different energy storage, because you may have seen that there's many technologies and it could be difficult to identify which one is good. And for this, I think to have some knowledge on battery fundamentals regarding the chemistries, the degradation, cycle life, efficiencies could help to make a good comparison. Another point is the service, the grid service that the battery can give, provide to the grid, and to have some knowledge in battery management service system, and power electronics, especially for the grid forming inverters that is coming now. So to have some ideas about what is this inverter, what it can do. It's interesting. I think to be aware of the grid code, of the queue process for the grid integration is key technical skills, because it's what allows you to continue in your project and to achieve your project. So regarding the effective integration, so you can design a very well battery, a good technology, safer and so on and so on, but if you cannot integrate it to the grid, it's worth nothing. I think it's a major skills for the technical parts. Regarding the industry knowledge, to be aware of the market design, again for the integration to the grid, so electricity markets rules, you have capacity markets, ancillary service markets, and so on. To have strong knowledge on this part is really fundamental, I think. You have also supply chain dynamics and technology roadmaps to be aware of what is going on and what could be the next 2 years, for instance, because developing a project could last several years, and so it's important to design your system for the following years. And I think that is. And finally, for the career strategy, so I think if you have the opportunity to pursue a hybrid project experience, I think it's a good thing, because today is the fastest growing project topology that is globally deployed now. So wind plus storage, or solar plus storage. So another strategy is to obtain certification as is possible for certified energy manager or project management certification. I think certification is always a key for improve your career. You have to learn how storage can earn revenue to understand how we can have benefits integrating storage and how we can finance this. That's why it's good to follow storage markets and to follow the market rules evolution. Yeah, I think to sum up, it's important to think like a system operator. So understand how your project interact with your broader power system. So to be aware of what is the other part, that just the only storage technologies. So you have the grid, you have the market, you have so the environment too. So it could be sustainable and yeah.
That's incredibly helpful advice. Thank you. To bring us to the end of today's podcast, thank you so much, Dominic, for sharing your insights and expertise with us. It's been a really insightful discussion, and we truly appreciate your time. And thank you to everyone listening. And I hope you found this session interesting and valuable as we did. And see you next time.
Thank you.